I have a question. What would the electric force, F, be between two dimes placed at opposite ends of a 10-meter table if their nuclear and electronic charges were unbalanced by about 1%? These dimes are made up of pure silver and are 2.5 grams. Okay, so to solve this problem, we are going to need Coulomb's law, which says that the force between two charges is equal to 1 over 4 pi permittivity constant, the charges divided by the square of the distance. Now this can be written in vector form, but in this case we won't need that because we can align our coordinate system that the distance is along the x-axis. We will need, however, a couple constants. First, we're going to need the permittivity constant. We're going to need Avogadro's constant. We're going to need to know the atomic number of silver. We're going to need to know the molar mass. And we're going to need to know the charge on an electron. So first thing, when you write down this equation, is we now need to work out the different components. Well, R is given, and R is equal to 10 meters. E naught is a constant, which is here. Now I have Q times Q, but the charge is going to be the same, so we can write it as Q squared. So now we need to work out what Q is. Well, Q results from the charge imbalance on the silver dime. So we need to first work out how many electrons exist in the 2.5 gram dime. Then we take 1% of that to tell us how many electrons there are that are unbalanced. Once we know the amount of electrons, we can then multiply that by the charge per electron to get us Q. The dime has a mass of 2.5 grams, and it's silver, so it has a molar mass of 107.87 grams per 1 mole. Then we multiply that by Avogadro's constant, 6.022 times 10 to the 23 atoms per 1 mole. And I'm going to carry it on down here. Multiply that by the atomic number, 47. Now the atomic number relates to the amount of protons, and it's a neutral atom, so the amount of protons equals the number of electrons. So it's 47 electrons per atom. And then we multiply that by 1.602 times 10 to the minus 19 coulombs per 1 electron. So we can see that by units, that we get something in the unit of charge, which is 1.05 times 10 to the 5 coulombs. So that would be the total charge of all the electrons. However, there's only a 1% imbalance. So we divide that number by 100, and we get 1050.8 coulombs. Now we put these values into our equation. And just real quick, we can look at the dimensions we have a Coulomb squared here and a Coulomb squared here, so they're going to cancel. We have a meter squared here and a meter squared here, so they're going to cancel. And we're left with a Newton, which is the unit of force. So dimensionally, this works out. So this equals 9.93 times 10 to the 13 newtons. To convert this to a pound force, for 1 pound, you have 4.45 Newton, which means that we have something like 2.23 times 10 to the 13 pounds. So what do you think weighs in pounds or in newtons of that order of magnitude? Now remember, we're just talking about 2 dimes that weigh 2.5 grams, and we just say imagine 1% imbalance, and this leads to an enormous force between the two. If you enjoyed this video, please consider giving it a like and subscribe for more content.